Tonight, I'm going to go over the results of studies that were conducted over a 3 to 4 year time frame and give you a little bit of history about how EPA got involved. But I think for most of you that were not able to attend our open house in December, it'll probably be maybe the first time that you've heard about the results of our study. So I've got about 20 minutes to go through the slide program. I'm not going to show you all the slides that we presented in December of 2012, but I'm going to try to cover as much as I can in the 20 minutes to give you a really good idea about the comprehensive study that was done. And also want to thank, of course, DOE, DTSC, and all the community members that participated in our technical panel. We had a technical panel established, which I think it's still ongoing, but several folks participated in that panel and actually reviewed all the work group documents that were used to actually study the site. So this is just a slide of the managers and the folks that worked on the project at that time. There's been a couple of changes. Jane Diamond is no longer head of Superfund. We have a new manager. His name's Enrique Manzanilla. And Mike Montgomery is also moving out of Superfund. He will be in the water division soon. But Lauren Henning is my boss. Mary Aycock, that's me. Andy Bain was in charge of the soil study. S.J. Churn was our chemist, our radiochemist on the project and handled the quality assurance. Greg Dempsey, who Dan referred to earlier, was our technical advisor. And as Dan said, you know, Greg's been involved with the site since the 1980s. So it was really valuable for us to have Greg there. Greg has a health physics background, and so he helped me design the studies that we actually did at the site. So Dan has already showed you the location. What I'd like to point out in this slide is that basically our study covered only Area 4 in the northern buffer zone. That was the scope of the work that we did. EPA's role was basically, we were appointed to do the work through a federal appropriations agreement, a federal appropriations law, which is known as House Rule 2764. What this rule stated was that it pretty much said that DOE and EPA would enter into an interagency agreement, which is now closed, but that agreement would be used to conduct a comprehensive study, a comprehensive radiological study of the site. And basically it would include site characterization of Area 4 in the northern buffer zone in accordance with CERCLA or Superfund. So basically HR 2764 gave EPA the ability to use CERCLA authority to go on site and actually conduct this study. The Department of Toxic Substances Control, DTSC, is actually the lead regulatory agency for the site, and they had been there prior to this under a RCRA corrective action, but DTSC still remains the main regulatory agency for the cleanup at the site. Part of this Appropriations Act allowed DOE to provide EPA with $41.5 million to do the study, including $38.3 million under the American Recovery and Reinvestment Act of 2009. So the money that was associated with ARRA pretty much had to be spent within a 2 to 3 year time frame. And so what was difficult about this study is we were trying to cram about a 5-year characterization study into about 2.5 years. The study also included doing about a year's worth of work that was a background study. And the background study was a comprehensive study to actually determine what the background levels were for some of the radionuclides of interest. And I'll get into a little bit of that when we talk about the results and what our analyses were compared to. So So again, this is a picture of the site probably as it was in the 1960s. The reason I like to show this site is, as you can see, as you know, when you're doing surveying of terrain, it's very difficult at Santa Susana because you have such a complex terrain, and you know, there's a lot of large boulders and a lot of areas that makes it very difficult to get equipment into. So our gamma scanning program that we did was designed to scan as many available acres as we could. And what it does is we used equipment that would pick up, you know, gamma radiation that was in the ground, and just ascertain what type of radioisotopes we had associated with what we were finding. We surveyed 266 acres out of about 471 acres, and I'll show you some of the results of that. This is our equipment that we used, starting with the upper side here. We're going from the most detailed or sensitive equipment, and if you go along like this, down to the least sensitive equipment, which is actually the handheld gamma detectors. But our workhorse for the project was called the Enhanced Radiation Ground Scanner, which was developed by a gentleman named Roger Shura along with Greg Dempsey in the Las Vegas office of EPA. And so basically what you have here is a series of sodium iodide detectors shielded in lead shielding and then mounted so that you could actually use a forklift on this very heavy instrument to actually scan different areas of the site. We also were able to put it on a lift and do the sides of the cliffs around the radioactive materials handling facility. We had dual detectors mounted on a track-mounted scanner. We had wheel-mounted scanners, single track scanners, and then the mule-mounted gamma scanners, which was another idea of Greg's, but it turned out to be a very successful use of actually having the animals with the detectors on them out at the site, and we were able to get into some areas that we would not have been able to with the other equipment. When we were confirming spots that we found that we thought to be elevated, we would take out HP germanium detector, and what we would do with this detector to actually confirm areas where we found contamination was we would do what's called a static count, where you put the instrument over a spot and you try to you leave it there for anywhere from 5 minutes to 20 minutes to see if you're really getting a reading or not. So the slides I'm going to show you are actually where we verified that we were finding contamination. Again, here's the wheel-mounted scanner, just another view of it. The track-mounted scanner, you can see how difficult it was to actually get into some of these areas. The ergs again, and then the mule-mounted scanners. But if you can see how challenging this was, I know some of you folks that did our congressional tour in 2012 were able to see most of these instruments and packages in motion out there and actually seeing them in use. So this is just an overall map. We'll get into more detail with this. It's difficult to see, but what you're seeing here is the blue areas represent areas where we actually did find and confirm that cesium-137 contamination was found at the site. It's difficult to see where the other elevated areas are, but I will note that some of the red areas that you're seeing here are actually outcroppings of rock that have a naturally high occurring concentration of uranium. But as we move on, what you'll see here is that what we found was, we called them grays. They were gamma ray anomalies. And this is in sub-area 6. So to orient you, let me see where we are here. Dan, is this the SRE area here with the black tarp?
That would be the mercury contaminated soil.
Yeah, okay, so the SRE foundation was here. This is a tarp that's there. But you folks that have been out there and toured, you know kind of where the black tarp is. So that's just to orient you. Basically, what we did find in Area 6 was we confirmed that there were actually 30 confirmed grays, gamma radiation anomalies. In other words, we were able to actually do further analysis in these areas, and we were able to show that there actually was cesium-137 contamination. Again, if you look at the black circles that are here, these are some of the areas where we found the cesium. The heavily blue areas here are where we were able to confirm it in larger areas, larger amounts. Another area, this is in the survey units, this was called sub-area 7. This is the area around the radioactive materials handling facility, which is fenced here. And then if you saw the slide that I showed you with the enhanced radiation gamma scanner on the forklift, with the fork on the front of it, this is where we actually did that scanning around the cliffs of this facility. The blue, again, in different colors, the darker it gets, the higher the contamination. So again, what you're seeing here is confirmed cesium-137 contamination. Any place you see the blue dot, this was actually confirmed in our study. So another part of our study was we did do surface water sampling. It was conducted in December of 2010. We collected 34 samples from the surface water. Samples at 2 of the locations exceeded the maximum contaminant level of 50 picocuries per liter for total gross beta. This is a technical term that's used for drinking water. But there was actually 2 locations where we did find exceedances. And so on the next slide, those 2 areas consisted of this point here and this point here. And so you can see that we did do quite a bit of collection here. And the only place that we did find contamination was in these 2 areas. But it does indicate that, at least for these areas here, you're seeing some surface water that is above drinking water standards. We did sediment sampling. A total of 67 samples and 4 field duplicate samples were collected throughout Area 4 in the northern buffer zone. Radionuclide concentrations exceeded what we call the field action level, or exceeded background, in 4 areas. Cesium-137 and strontium-90 and plutonium-239-240 were detected down gradient of the sodium reactor experiment, and I'll show you a map on that in a minute. Strontium-90 was detected down gradient of the radioactive materials handling facility. Strontium-90 was also exceeded our field action levels at 1 location in the western portion of the northern buffer zone. I'll show you where that is on this next map. And then cesium-137 also exceeded our field action levels at 1 location down gradient of the building 4009 leach field. So on the next map, you can see the orange dots represent where these exceedances were found. And so we had 1 here, 3 here, 1 here. This is the one that was out near the buffer zone, and then another one in this part of the buffer zone. And this must be the one near the building 4009. Okay, another aspect of the project was groundwater sampling. We did 2 phases. We sampled 80 wells in Area 4 and 13 wells offsite. We collected a total of 161 groundwater samples. In those, we detected tritium in 3 of the Area 4 wells that were above the maximum contaminant level, or MCL. We detected strontium-90 in 1 Area 4 well that was above the MCL. The results of EPA's characterization study confirmed what Boeing had previously found in their data. So this part of our study was being done We were asked to do it to confirm previous results that Boeing had actually, performed, and we were able to confirm that yes, they were finding the same levels of tritium and other components in the groundwater as we did. Very hard to see, but again, this is the location of the groundwater wells. And if you came to the open house, and if you look at our documents, we have numerous maps in the documents that you can fold out and actually read the values yourself. But again, just this map just gives you an idea of the locations of where those groundwater where those groundwater wells are located. We did a surface and subsurface soil investigation. This was probably the most extensive part of the work that we did there. This is pictures of the folks that worked for HGL that were out on the site. We had, at any one given time, we had up to 50 workers on the site pulling soil samples. So the soil sampling was conducted in 2 rounds. The idea was that if we found any exceedances, or if we had areas that we suspected an exceedance, then once we got those results back, the idea was we would step out from that particular point. So in area 4, and under round 1, we collected 2,490 samples and 131 field duplicate samples. In the northern buffer zone, we collected 233 samples with 13 field duplicates. We did deep boreholes in the areas where the foundations of certain buildings were located. 18 samples and 1 field duplicate were done for deep boreholes. And the soil sampling was actually completed in May of 2012, the round 1. Round 2 soil sampling was what was known as the step outs. As I told you, if we got exceedances from round 1, we would step out from that location to see if there's anything around those. We collected 734 samples and 44 field duplicates were collected in round 2, and we completed that in July of 2012. And so this is just a graphic representation of actually how many samples we collected. And when people ask me, I say roughly 3,500 samples were collected in Area 4. The actual number is here, 3,459. And that does not include all the duplicate samples that were taken as part of, for the quality assurance purposes. Just pictures of the surface soil sampling. And then here's the results. This is, I think, what a lot of folks wanted to hear about as a result of our study. They wanted to see, what did you find, and how does it compare to the backgrounds that you guys found in your background study? So what we did find was for cesium-137, we're using 0.193 picocuries per gram for the background or the field action level. We had 291 exceedances. For strontium-90, our background or field action level was 0.075. We had 153 exceedances. Europium-152, cobalt-60, and so on down the line. You can see, the representation of operational type radionuclides that you would expect to see, in a nuclear reactor environment. So, because I've got 1 minute left, this is a lot of information. The website that we have up now on Region 9, we've actually posted most of these documents, and we've also posted the presentations that we did over the years. I was on site for approximately 2 years, and before that, a year before that, worked on the background study with Nicole Mutu. So I will be here for a while. If you have questions, please come and talk to me. Otherwise, please feel free to visit our website. We're no longer working at the site. DTSC is still the lead, but we do provide technical support to DTSC. And thank you very much for your attention. Appreciate it.